Hi, this is Miss Goodwin. Today we are going over objective 5.1, which is that I can use the arc length and sector areas to find missing measurements. Remember, we want to be at level 3, which says that we can solve for both the arc length and the sector area when given the other. Before we do that, let's look at some vocabulary first. Our first term is the radius, which is half of the width of the circle, or the distance from center of the circle to edge of circle. So in this diagram here, that would be like drawing a line from point O to point C. And remember, this is half of the width. Our next term is diameter. Diameter is the line passing from the one edge to the other through the center of the circle. And this is the full width of the circle. So in this little picture here, that would be like if we drew a line from point A to B. This is our diameter. Our next term is circumference, which is the distance around the circle. So the length of the outside of the circle is the circumference. You might also hear referred to as the perimeter of the circle. And lastly, the area is the space occupied by the shape. And it's not exclusive to circles, we're just working with circles. So however much space is inside that outer border, this is our area. Okay. Remember, the formulas for circumference is 2 times pi times the radius, and the formula for area of a circle is pi times the radius squared. Now, think of a circle like a pie or a pizza or something, or a cake. And we want to cut a slice out. That will give us our sector. So if we draw 2 radii, we do get what's called a sector, which is basically our slice of pie. Okay? So like right here, this is one radius, this is another. Now, that we can find the length of this arc. The arc length is the distance between 2 points on a curve. And the sector area is the space occupied by that sector. We do have one more term that I did not put in here, and that is the central angle. And this little symbol theta will make a comeback. This is the angle between the 2 radii. Okay. So in this little diagram here, this is point S, R, and Q. And we got a little angle here. That is our central angle. Our arc is this guy right here. Arc SR. And the sector is SQR. That's how we name the sector. Now, we do have a few key formulas here, but before we do that, let's do a little bit of... Right, we do have a couple key formulas we will be using, but before we do that, let's talk about the fraction. Every circle has 360 degrees. Okay? Now, this sector is only part of that circle. So our fraction is that angle over 360. So that is the fraction of the circle the sector takes up. Okay. Now, remember, our formulas for circumference and area are 2 pi r and pi r squared. If we take those and multiply them by this fraction, that gives us our sector area and arc length. So the arc length formula is 2 pi times the radius times our angle over 360. Now this can be simplified to pi r times our angle over 180 if we divide the 2 and 360 by 2. But both of these work. Now for sector area, our formula is pi times the radius squared times our angle over 360. These are your key formulas. If you took note of nothing else, this is what you want to know. Now let's do a couple examples. Okay. Our first example says in a circle E with angle DEF equals 48 degrees and DE is 6, that is our radius. We want to find the length of arc DF and the area of sector DEF. Okay. We know our angle is 48 and our radius is 6. All we have to do is plug them into both of our formulas, both of our key formulas. So the length is pi times 6 times 48 over 180. And the easy way to do this is to just throw it all in a calculator. Ignore that. So all calculators will have a pi button times 6 pi times 6 times 48. Divide that by 180. That gives us 5.026, which rounds to 5.03. And that is the length of our arc. Now we also need to find the area of our sector, which is going to be pi r squared times our angle over 360. So that is pi times 6 squared times 48 over 360. And again, just throw that into our calculator. Pi times 6 squared times 48 divided by 360 is 15.08. And those are our arc length and our sector area. Okay. So in circle H with angle GHJ equals 60 degrees and GH equals 16, find the length of arc GJ and the area of sector GHJ. So the formula is 2 pi r times the angle over 360. Plug in everything, we get 2 times pi times the radius 16 times our angle 60 all over 360. 360 and 60 can simplify. 60 to 1, 360 to 6, both of them are divisible by 60. 2 and 6 reduce because 2 and 6 are both divisible by 2, so that gives us 3. And now we have 16 over 3 times pi. Or we could rewrite this as 16 over 3 pi. There we go. Now, find our sector area. which is pi times the radius squared times our angle over 360. Area equals pi times 16 squared times 60 over 360. The 60 and 360 reduced to 1 over 6. 16 squared, I know, is 256. I'm just rewriting this a little. Okay. 256 and 6 are both divisible by 2. We get 128 over 3 times pi. And that is our arc length and our sector area written as a fraction times pi. So you might have to do either one. You do not have to find the decimal in this case. Okay. Now for our next example, this is level 2. We are given that in circle J with the angle KGJL equals 72 degrees and the length of arc KL equals 6 over 5 pi. We want to find the length of JK. So we are looking for the radius in this case. We have our angle of 72 degrees and our arc length 6 over 5 pi. Remember, this is our formula for arc length. L is the arc. So I'm going to plug that in over here. 6 over 5 pi equals 2 pi. We don't know our radius, but we do know our angle is 72 over 360. Okay. I do see we have pi on both sides. If we divided both sides by pi, that would cancel out. I also know 2 and 360 cancel out to give us 180 here. And then both of these are divisible by 6. But that's fine, as is. So all we have is, right now, is 6 over 5 equals 72 over 360, or 180, my bad, pi. I'm just going to multiply by the reciprocal of the fraction here. Okay. 6 and 72 reduced to 12. 180 and 5. 180 divided by 5 is 36. 5 divided by 5 is 1. So all we're left with is 36 equals the radius. Holy cow. I keep messing up. I'm sorry. But yes, our radius is 36. So right now we have 36 over 12 equals our radius, which reduces to 3. So our radius is 3. Okay. Let's look at example 4. We are given that in circle V, VW, which is this line from V to point W here, is equal to 4. And the area of the shaded sector, WVX, is 4/3 pi. We want to find the measure of the angle. Okay. So remember, sector area equals pi times the radius squared times our angle over 360. This time we are looking for our angle. We do have our sector area, so that will go in the A part of the formula. So 4 over 3 pi equals pi times the radius, which is 4, squared, times our angle, which we don't know, all over 360. Just like in our last problem, we can divide out the pi's. Okay. And then I know 4 squared is 16. So right now we have 4 over 3 equals 16 over 360 times our angle. And just like before, I'm going to multiply by a reciprocal on both sides. So now we have 360 over 16 times 4 over 3 equals our angle. 360 and 3 reduce, that's 120. 16 and 4 reduce, that gives us 4. So now we have 120 over 4, which is just 30 degrees. So for level 2, you just have to be able to find either the radius or the angle given the arc length and or sector area. Example 5, we're going to take that a step further with our level 3 problem and find the length of the arc given the sector area. So we know that the measure of our angle is 120 and that the area of our sector is 3 pi. But we want to find the length of the arc. First, we have to find the radius. And I'm going to do that just like I did the previous problems, okay? Remember, area of the sector is going to be A equals pi r squared angle over 360. So we get 3 pi equals pi times our radius squared times 120 over 360. Just like before, our pi's cancel out, and 120 over 360 can be reduced to 1 over 3. So right now we have 3 equals r squared over 3. Multiply both sides by 3. That gives us 9 equals r squared, which we had to take the square root of to get 3 equals r. Okay, that's level 2. Level 3, we just throw that back in to the arc length formula. So the length is equal to 2 times pi times our radius times our angle, all over 360. 3 times 120 is 360 over 360. Those reduce, so we get length equals 2 pi. And we don't have to find it as a decimal. We could just leave it like that. And that is how you find one given the other. That is all I have for you today. Have a great day. Bye.